Anyway, the smart house. My name's Darryl Smith VK2TDS and I'm a consultant engineer, electrical engineer. The alternate topic for this is why are my lights coming on at 3 AM? And it wasn't me causing them to come on. Okay, and by the way, that's a picture of the plane just there with me at it. And that's at Kaiguna. I'm a consultant engineer. I'm looking for interesting work. If you know of anyone who wants weird and wonderful electrical engineering stuff. I've had a high voltage license in the past, IT, you name it. And this presentation does concern some home automation experiments I've done. I had a consulting job where I could work from home and claim most of what I did on this project as work. So that's why most of it got done. And a ham radio friend of mine thinks that I've got a business card which on the back says, only does cool stuff. And by the way, my business name is called Radioactive Networks. Radio stuff. So. Okay, and by the way, yesterday I took my first flight, first solo, and that's me after my first solo in a plane. So it took me a long time to actually get round to learning, but I'm actually now flying the plane myself. Okay, so here's my home. I live in Ingleburn, which is southwest of Sydney, and so this gives you some context for where I actually live. The key components of this is a lighting control system, our alarm and infrared sensors, some water, a doorbell, a weather station, some web control, HVAC, heating, ventilation and air conditioning. It's just a way of including everything with heating and ventilation. It's called HVAC. Some energy management, talking about my fireplace and some picture frames. And those last ones you're thinking, what is he talking about there? But we'll get on to that. A lot of the detail I can talk about in greater detail if you're interested, and I can give you a copy of the presentation. But I'm also going to gloss over a lot of it. I think I need to redo the presentation. I've only given it once before, and I really need to rip a few bits out because the content really doesn't work in a few spots, but I need to improve it. So lighting control system. Sometimes the cheapest way is brute force, which is a way of what I was trying to do here was I want to monitor both the lights and the light switches in my home. Basically, there's almost no behavioural research being done as to how people use their house, how much energy is saved by people turning lights off, how often people forget to turn lights off. There's almost none of that sort of research, and so I decided that maybe that was a good idea to start collecting data. And so I came up with a solution with this. It was a bit of brute force. I decided that I wanted to control every single light in my home. I have about 55 of them now. And you may think, well, that's a bit excessive. Well, I'll get to talk about this a bit more later, but my lounge room has actually got 13 lights in it. Because it now has 12 compact fluorescent downlights, each of them individually controlled. So it's really not that bad. Also, I want to monitor every single light switch, of which I think I have around 40 or so light switches in my home. So a few less. I want to monitor the inputs and outputs, and the best way I decided was that I had to rewire the entire house to do this. So I installed something like 2 kilometres of mains cable to do this. So I wired every single light switch and every single light back to a huge board with relays and input cards. Something like this. And so on this side, these are the standard plug-in relay, 12-volt relays. Coming into here, a circuit breaker on each row. And so these are RS485 output modules. I've got software that turns relays on and off based on RS485 network. And so when a light turns on and off, it turns the output module on, which drives the relays. I broke it up into rows like that, so I could isolate a particular row, and if something happened, I'd only lose a few lights. And I've since found that that's a fantastic idea because compact fluorescent screw-in lights, I've found when they fail, they often fail as a dead short. And so that's one of the problems with them. So having the multiple overcurrent sensors helps. The other thing is, by putting breaking the current up like that, I made sure that the current on my each line was less than 10 amps. Therefore, I could use 1mm wire, copper wire, which meant that I could reduce the cost of the install significantly. So there was method in my madness, and there are actually 2 cabinets of relays.
I take it your light switches have only got 12 volts on them now then, don't they?
Yes, but I used 240 volt cable for them. And the reason I use that is that they can then, I can retrofit and get rid of the control system if I want to. And secondly is that I could run the 2 cables down the same piece of conduit and next to each other, because I used the cable rated for the highest rating. So I put some thought into this. And by the way, I'm not an electrician. I have legally done electrical wiring unsupervised in the past when I was working for the Electricity Commission in New South Wales, but and I also had a high voltage licence. So I used to be able to work on anything above 1,000 volts as well, and have. Not live though. Best I've ever worked, I have repaired a 240 volt DC battery charger that was capable of, I think, 500 amps, continuous, connected to a set of batteries with a 60 kA fault current, and we put those batteries onto a dummy load. Controllable to 1/4 of a watt at 250 kilowatts. And after half an hour at 250 kilowatts, the battery is barely registered. So this is a bit closer with the relays. I actually need to do a bit more work because you can stick your fingers down the holes, which doesn't comply with AS3000, but it's getting close. The input cards, RS485, you can see the wires here. That's 12 volts, so there's no problem with me touching it, therefore it doesn't need to be insulated, thankfully. So I can work on those live. And there's actually now another 2 input modules. So all the input modules are now installed. Just another version here. So I've got 225 amp circuits feeding all the lights, of which I don't need much. And I've also got an earth leakage unit there, so I can now also do things like have some lights outside, and also I don't need to worry about some issues with where the cable's going. Earth leakage units make it possible to get around most of the regulations with regards to energy installs, apparently. Let's see, I think I've spoken about most of the other points there. So basically, right now, I've got software where if I turn a light switch on, that goes into a computer through the RS485 network. Software determines what should happen then, and then it goes to an output module and turns a relay, which is a bit of brute force, but it works really well. So the second part of this system was an alarm. When my mother died and I inherited the house and decided to do a heap of work, I also decided that since there was no longer someone else there, I needed an alarm to go to make sure that the house was being monitored. And so I wanted a few things from the alarm when I installed it. But I also knew that the sensors could be very, very useful also for research. What I wanted to be able to do was to monitor movement inside the house and to act as an alarm. The movement was probably just as important as the alarm functionality. Passive infrared sensors are fantastic. They'll tell you when you're moving in an area, and so what I wanted to do is to be able to correlate that with light switches and work out whether lights and light switches were on or not, and work out how much of a saving there was by if you turned lights off and how often you left things on. So there was a link there. And so eventually I actually chose a NES M1 alarm with an Ethernet interface because I wanted to be able to get all the data out of it. About 6 weeks before I bought the NES alarm system, I bought one from Bosch, and it's now in my brother's house. I worked out that the interface for that was far, far, far more difficult to control and found the NES. One of the problems I did find with the NES with the alarm when I installed it, was like I've got something like 2 kilometres of Cat5 cable in my house. So the house is wired. You'll see that in a bit more in a minute. And I'm a licensed comms cabler as well. And so I really didn't have any Wi-Fi equipment. And a few times I've been using Wi-Fi since since a Wi-Fi router cost $650 on special. I did my undergrad thesis on what became Wi-Fi, on spread spectrum half duplex data communications. So with that in mind, I hadn't been using Wi-Fi and had no real need for it because the speeds weren't all that great. But since in the intervening time, there was a few times that I tried to get Wi-Fi up and running again, and it wouldn't work. And I think, what load of rubbish is this router put into the pile of equipment? Oh, this one looks better. 6 months later, try it again. It works, but only when it's this far away. Boring. Put that. Buy a Wi-Fi picture frame. Doesn't really work. Get rid of it. Then I decided to try and work out what the problem was. And I think it really can't be that hard to get Wi-Fi actually working. And so I decided to...
Turn your house into a Faraday cage.
Well, it was tempting, but that wouldn't have helped turning the house into a Faraday cage. Because I did some investigations and found that the Faraday cage wouldn't have helped my house. It would have helped the neighbours get their Wi-Fi working again, but it wouldn't have helped my house. It turns out that I had an interference issue with 2.4 gigahertz. The PIR sensors that I bought had radar functionality in them, and unknown to the ham who sold them to me, who's a professional alarm installer, have a guess what frequency the radar ran on of these passive infrared sensors? 2.4 gigahertz. And I had 10 of these things in my home. So as soon as I turned them off, you can imagine what happened to my Wi-Fi connectivity. And to my neighbour's Wi-Fi connectivity. They were rather appreciative when I spent an extra, $700 on new passive infrared sensors with with the 10 gigahertz rather than 2.4 gig. Anyway, so this is my alarm with all the... One of the things I did with my alarm, once again, rather than go for the cheap alarm cable, what I did was actually use Cat5 cable. A, it's cheap, and B, it means that I can run it right next to all the other comms cable. I've actually also, what you can't see here, is put a patch panel for all the alarm sensors. So all the alarm sensors actually go to a patch or chrome block, and then I've got a heap less cables coming across to the actual alarm. So that if I ever want to replace the alarm, it's only 2 blue cables rather than 32. Because one of my hates is with alarms is you try to get so many cables in it, it's a pain. Anyway, so one of the problems I had with my alarm is my alarm actually turned on? Great problem. Did I remember to turn it on? The Nest alarm has an iPhone app, but at this stage I didn't have an iPhone. Well, actually, I must have actually, but I didn't really like to use the iPhone interface. So what I did was, I wrote a tiny bit of software to send me a short message whenever I turn my alarm on. I use a program called Prowl, which allows you to, through a web interface or something else, or through Python, so that whenever I turn the alarm on, within a few seconds I actually get a message on my iPhone. And so as soon as I'm driving out by the top of my driveway, I've had a beep on my iPhone, and it's there until I use my phone next. Or I can actually have a look at it. It's a great reminder. One of the other things I did, I got some money for a birthday and I'd actually cleared my garage. I was thinking of actually building my own plane as well, so cleaned the garage and put But what I decided to do was put a garage door opener there. My alarm has a few extra relay outputs that you can use on it. And so I decided, my alarm has 2 spare buttons, a blue one and a red one. My ham radio alarm installer reckons they're the Jesus buttons, because Jesus only knows what they do. So what I did was I reprogrammed those 2 buttons within the alarm system, so that when you press the red button, it closes a relay for 2 seconds, and then also turns the alarm on. Whenever I press the blue button, it closes a relay for 2 seconds and turns the alarm off. And so what I found was there's an undocumented interface with the garage door opener. There's a switch input, so that if you buy their special push button switch, you can actually open your garage door opener, or open the garage door without the using the remote. So what I did was, I thought, what could they be doing here? So I put a relay on it and closed it, and surely enough, the door opens and closes. So what I did was hook that up to the alarm and reprogrammed those buttons, so now the door opens and closes through the remote control of the garage door, which means one less remote control, which is pretty useful. The other thing is, the other problem was that I could never remember whether or not I was having the problem of remembering to press the unlock the alarm button and then press the button to open the garage door by having 2 buttons, 1 button for each. The only issue is that at the moment the system doesn't know what the state of the garage door is, and so if you decide to press the red button when the door's already shut, it opens it and turns the alarm on, and then sets the alarm off.
Needs my logic there.
Yeah, need a bit more logic. So one of the other things is a bit of crossover here. Here is the infrared sensor, this is in my kitchen. So then I've got a bit of crossover. Here, this is my kitchen with a standard fluorescent light globe, like one of those with the 2 fluoros. What I did, I mentioned 55 relays earlier. One of the reasons is, how many relays do you think I used for my kitchen light? 2. Well, actually, I've got 4. 1 for the exhaust fan, 1 for the light above the stove, and then 2 for this fluoro, so that I can control both fluoro lights independently. So, just inside the kitchen door, there is actually 3 switches. One of them is now a 2-way switch, so that the one above the stove can be turned on or off from the door. And that's good because it's only like a 20-watt, very short fluoro. So it provides a bit of light there if I need it. Then the other 2 have a very important use. One of them turns both fluoro tubes on, the other one only turns 1 fluoro tube on. So I've got less light if I don't need as much light. But the other thing is, with the control system that I've got, is that it's connected up to the passive infrared sensors. So the software for the passive infrareds is the passive infrareds are on the alarm. Then I've also got a separate bit of software to do the lighting control. But the lighting control also now loads the information from the alarm. And so if there's no activity, if the light in the kitchen is on, after 10 minutes, and there's no activity, one of those fluoro lights gets turned off. Which gives me a few seconds, or 2 minutes, to wave my arms round and before the second one turns off. So I'm never actually left in the dark. You'd be amazed at how often I actually walk into my kitchen and have the lights suddenly turn on. Even sometimes of a morning, I walk into my kitchen and the lights suddenly turn on because I've forgotten to turn them off the night before. And one of the major issues with energy consumption isn't, there's not really that much energy used in the home for lighting unless you've got halogen downlights. One of the issues is lights are left on by accident. like the 150 watt or the 500 watt spotlight or outdoor light that you've forgotten to turn off. That's the real killer. And a great way to work out how much a light that's on 24 hours a day is costing you, double the wattage. So if it's a 20 watt globe, that costs you about $40 a year. It's actually a bit more than that, but that gives you an idea. So if you've got a light or a computer or something that's always turned on, a Foxtel box at 15 watts that's always turned on, $30 a year. So a little hint for you. Patch panel. I've already mentioned how much cabling I've got in my home. And so what I've got in my home also is I've got coax plus Cat5. Cat5 is great for data and some other uses, and the coax is used for video. One of the things that I've found out is that in a cabling install, something like 60% of the problems you'll have will be cabling issues. And most of those will be caused when you disturb cables, as in when you pull a 19-inch rack out to look at where all the sockets are, add more wires, etc. Whenever you touch something, you're liable to cause problems. So what I've worked out is that basically if you've got a home situation, stay away from anything that's 19-inch. You should never put a 19-inch rack in a home. Instead of doing that, and we'll show it in a minute, use standard Australian wall plates. And that means that if you ever need to change stuff, you pull 6 wires out instead of 24. And so you're less likely to pull wires, you've got less weight, it's going to be more reliable. This is from hard experience here. What I've also got with the video is, I've got 2 video sources coming into the home. I've got Foxtel and I've got a TV antenna. And so they both come straight into the patch panel. Then from there, I have 2 coaxes going to my Foxtel box. Those same, so they're straight looped through. Then, out of the Foxtel box, there's an antenna output, which is modulated video, plus all the normal sort of TV antenna. So that goes back to the patch panel. And back at the patch panel, I've then got a standard antenna splitter, and so that goes to 4 different locations throughout the home. So now, I've got Foxtel in actually 5 places in the home. It's the same channel, but I've actually got sharing my Foxtel with 5 different rooms. So, you're thinking, yeah, but how do you change the channel? So, I bought a, J-Car has got a kit you can buy for an infrared remote control extender. So I built one of them. And how do you think I get the cable round? Well, Cat5. So I have the receiver in my bedroom, have it fed through the Cat5 to the patch panel, patch that straight through to the where the Foxtel box is, and have it come out. So the Cat5 is used for more than just Ethernet. It can be used for data. My weather station, which runs RS232, uses that. My solar install, which uses RS485, uses Cat5. Same sort of thing, as just patched through. And this gives you an idea here. I've actually all the wires come through from behind now, and whenever I add wires, I just populate more and more of the holes, and so, and there's enough slack on the other side of the wall so that there's about that much spare, which means that it's actually a much more reliable install because of it. I've also put a heap of power outlets above, although I'm actually wanting to get rid of a few of those. I've got a heap of equipment that runs on 5 volts and a heap that runs on 12 volts, so I actually want to have some battery-backed DC distribution. This is actually, one of the other things on my patch panel is, I've got a brick wall there. That's a disaster if you want to mount equipment. So what I've done is got some 12mm chipboard and bolted it to the wall. Then I just use self-tappers into the wood, and I can mount any of the equipment. 2 self-tappers for the weather station, and then the equipment slides on. Now if I want to change it, undo it, and you don't need to go into the brick wall. Let's see, this is an Ethernet to RS232 interface to connect to the home control system. I've also got another one for the weather station there. That's a phone modem, which by the way does have some use, which I'll talk about in a moment. And yes, there really is still a use to buy a good old-fashioned serial phone modem. They're hard to buy, but they're very useful. This is just another view showing a zoomed out version. All the controls, relay controls are now just there, and you can see the huge bundle of cables before I had them back mounted. It looks messy, but it really isn't that bad. So some other sensors. One of the other things I wanted to do was, I've got this fantastic thing called off-peak hot water. It means that my hot water bill for a quarter is like $25. It's so much so that when I had the assessment for the green loans energy thing, that my home system, how little I paid, blew them out of the water and caused a number of issues with their reports. So much so that I wrote a report to the Senate inquiry pointing out the number of errors in their reports being. So one of the things I wanted to do was to actually monitor how often my off-peak hot water system was getting energy supplied to it. And so what I did here was a 240 volt relay, and then had that feed back into the same system as all the light switches. So that's effectively a light switch. And you might see this little loop there. That's so that I can put a clamp meter above it if I wish, and actually monitor the current consumption. But I no longer do that because I came up with some other better ways of doing it. And notice it's all behind a clear perspex thing, so I can't actually touch it, so it's nice and safe. I also monitor, and you can see the beautifully mounted Cat5 cable there connected to the little black box here. This is the water inlet into my hot water service. That's cold water going in, and that's a $50 water meter from JCAR. So I'm monitoring the water usage in my home every second. And I can now correlate that with regards to my electricity usage, and I can tell you how much energy is used for each shower. What I can tell you though is that it's about the water cost versus the water heating cost is about 1 to 3. So it costs 3 times as much to heat the water as it costs to actually buy the water. So showers cost me about 40 to 50 cents per shower. So it's interesting being able to look at that. But I also monitor the cold water usage and can correlate that through as well. Here is the VK2TDS-5 weather station, just on the top here. Once again, the sensors are run over Cat5 in the roof. One of the things when I was doing the rewiring, I put 3 controlled outlets in the roof space that I could connect to lights, and I put a heap of Cat5 inside my roof as well for various stuff. And we'll get to that in a minute as well. So, what's the software architecture on this? Basically, it's all mostly written in Python, it all runs under Linux. And basically, I've got a heap of individual scripts, and they create an intelligent system when put together. And adding more functionality involves just adding another script. I really need to improve the architecture. Basically, I've got a VNC terminal running, and I've got something like 15 different tabbed terminals on it, because each thing runs in its own little space, but it works really well. Means that when I have a power outage, it's a pain to get everything restarted, but it works. So, how it all works is I've got this thing called a PubSub Server. Publish, subscribe. Basically, the idea here is that you've got data points, or you've got things that publish information, the information being data points and values, and things that can subscribe to that. And so I've got one central piece of software where all the information comes in and all the information comes out. It's actually through, I got the idea through this thing called a protocol called XMPP or Jabber, that realised that for the people who were working on sensor networks for XMPP really didn't know what they were doing, but had some great ideas, and also trying to get XMPP to actually work was impossible because most of the functionality was undocumented, and you needed to deal with XML, which is always interesting, and then had to deal with all the undocumented features using style sheets and everything else, which is stuff I don't understand and was a disaster. So rather than try and persevere with that, I paid a rent-a-coder a couple of $100 to write a simple server for me, and it worked really well. Yeah. To give you an idea, so the client, a solar client, has a data point of value of 2343. A thermostat has an outside temperature of 13, an indoor temperature of 12. HVAC has temperature of 22, a mode of heat, a fan of load. And I'll just explain how this works. So let's say I've got an air conditioning unit, or I want to turn my air conditioner on and set it to 25 degrees in winter in my home. So I've got a bit of software that either through a remote control or through a web interface or whatever, I just say set the mode to heat and the temperature to 25 in the PubSub Server. And it doesn't need to know anything more than it needs to put the values there. Then, other software, it just needs to know that, assume that other software will listen to it and know what to do. It doesn't need to know how it gets done, it just needs to know that it will happen. So what happens then is the air conditioner actually listens to the same piece of software. It's only listening to the HVAC stuff, so it's doesn't worry about any of the lighting stuff. So it's doesn't have to try and filter all those out. It just listens to the HVAC stuff, and then it controls my air conditioner based on it, which is a pretty powerful concept, and it's actually fairly simple when you realise it. Here's the code. You probably can't read it, but basically they're just subscribe statements, and so this is all the subscribes needed for my home control system, and then it's one piece of software that does the lot. So it's a very, very powerful system. It also means that I can write a single program. I can write one program that will log all the data, for instance, and as soon as anything new comes in, it just works out that there's something new there, it will log it. I don't need to teach it about new stuff, it just discovers it. It also means that if I want to have add a new source of data, I can just easily add it that way. And if I've got to find something I want to try out in terms of something to use the data, I just write a quick script to subscribe to various bits, try it out, and then it can also upload new data. So what I might do is I might listen to information from the weather stations and change the air conditioner based on that. So it subscribes, then publishes. So the next thing I want to do was, we've had this fantastic thing called the Home Insulation Program from the government. So I thought, does ceiling insulation actually work? And so there's this thing called one wire, which is actually 2 wire or 3 wire. It's 1 wire plus ground or 2 wires plus ground, depending on how you run it. But basically, this little thing there looks like a BC547 transistor. So that's packaged. And it's got a laser-trimmed thermometer in it. And they're very, very cheap. And they're a digital thermometer, so none of this analog rubbish that we all have to deal with at times. And it's calibrated, and on a single bus, you can have something like 50 of these thermometers on a single twisted pair. And so I thought, why don't I play with this and get this running to monitor the temperature of my ceiling space? And so I bought myself an Arduino. I'd never tried the Arduino before, But within an hour of opening the box that the Arduino came in, I not only had it working with the software working on the Mac to program the Arduino, but I also had this circuit on it and the software running all in an hour. They're that easy to get working. They're quite amazing, really. And so yeah, so you can't. This is the A-frame of my house. It's very hard to see, unfortunately. But basically, what's saying here is that the temperature at the top of the A-frame is 8.25. It's 8.13 degrees here, 8.13 in the middle, 9 degrees up just above the insulation, and under the insulation on the gyprock of my ceiling, it was 14.13 degrees. So that's saying that there's basically 5 degrees temperature difference between both sides of the insulation, which basically says that it works. And to give you an idea of the PubSub Server, each of the temperature sensors has got a separate ID, and this is just me looking at the one particular sensor, having it go from 19.81, 19.75, 19.81 degrees every however long. And it just keeps polling and polling and polling, and as soon as it finds anything, it sends it out. Oh, the other thing about the Arduino, it's a USB serial device. So no searching for serial ports either. But you do a printf and it comes out in C, and it basically just comes out, the data comes out on the PC. An internet doorbell. Basically, the other thing was when I got the house was I needed a doorbell. Well, I wanted a doorbell. And has anyone here tried to buy a decent doorbell recently? And it's impossible to find one that looks decent. The best I could find was this little video intercom from Wes Components. And by the way, anyone who doesn't know about Wes Components should check them out. But when you've got an account with them, a cash account, that doorbell in colour is $50, and in black and white is $40. So what I worked out was that the best doorbell I could find actually had a video camera with it, and wasn't that much more expensive than the ones you buy from Bunnings anyway. And so what I did was actually wired that as an analog sensor into my alarm system. And so when you press a button, it actually tells the alarm that someone's at the door, and it says front door, just to tell you that there's someone there.
Exterminate.
Unfortunately, exterminate's not on its vocabulary. Yet. However, there was I've mentioned the PubSub Server recently, or a few moments ago. So what I've done here is that the doorbell is actually on the alarm, and the alarm goes to the PubSub Server, which meant that I also had come up with the alarm notification, which uses this thing called Prowl. And so that's also going through the PubSub Server. So what I decided to do was to extend things a bit. So monitor doorbell. Whenever the doorbell is pressed, send myself a message to make sure I'm at the, in case I am not home, or I'm in the garage, to tell me that there's someone at the front door. What my next trick is actually going to be connecting the video camera up, digitising it to send me a message with the photo.
So you'll catch the courier if he doesn't turn up.
Exactly. Unfortunately, I've already taught most of the couriers to leave stuff at home. It's actually the neighbours who press the doorbell when I'm not home, and I'm thinking, oops, I'm only 5 minutes from home. Do I go home to see who it is, or who is that? So that's the photo is needed. But the path is a tiny bit convoluted for pressing a doorbell. If you press the doorbell, it goes to the alarm. It goes to a script, goes to the PubSub server, goes to another script, goes to the Prowl server in the US, goes to the Apple's server, then goes to my iPhone via Telstra. So work out the number of hops in that. Surprisingly, it actually does work. Now, I've already talked about the alarm. Yep.
What's the quickest between pushing the bell and you getting a notification?
What do you mean?
How long does it take?
Oh, how long does it take? A second. Exactly. It's good. I mentioned a moment ago that I have a modem at home, a phone modem. Can anyone think what use a phone modem would be in this day and age?
Doorstop.
Wrong. Next. What?
Signing into VBS?
No? Good.
When you have Coke machines at random.
No?
Probably don't do
So you can dial in and restart all this system, remote.
No, I've got ADSL for that. No, I do actually have a use.
You can extend the RCP too.
No? Missed call notification. Most modems have got caller ID on them. And so I've got caller ID, I subscribe to caller ID, which means that the computer now knows the phone number of anyone who rings and when they ring. So if the alarm is turned on and someone rings, it immediately sends me a message with their caller ID. If it's turned off and I don't answer within 4 rings, it sends me a message. Since I've probably forgotten to turn the alarm on anyway, or I'm on another call and maybe on my mobile. So this is also one of the other things I tried with using the PubSub Server, which makes it extremely easy to do this sort of stuff. So that's a use for phone modem. One of the projects I want to do is to actually turn that into a USB plug-in device that doesn't cost $80, because it's actually not that hard.
So, I mean, you've got to do an AT command sequence to pick that up? I mean,
No, it's actually it automatically comes out. You tell the modem to respond it. It's like the ring signal. It says ring and then gives the phone number if you tell it to. So it's an AT plus something that it will respond to you. So you've just got to tell
so
it.
you're just monitoring the serial port off the modem? And
Yeah.
Yeah, and you just...
Yeah, and I also just send an AT command to the modem just every minute or so just to make sure it's still there and hasn't fallen asleep.
Get your OK back.
Yeah. So use for the things. One of the other things I did was monitor my solar install, and I've got a few bits of software there. One which downloads the information into the PubSub server, and what it does is actually implements Modbus, which is an industrial control system, to download all the data, shove it into the PubSub server. I've also got another script which then uploads the data every 5 minutes to the pvoutput.org. It shows that I've probably got the world's worst 3 kilowatt solar install. Basically, I knew that when I installed it because I've got a huge number of gum trees and it performs about the same as most people's 1 kilowatt system.
trees.
Yes. Okay, dplg.py, it's a Python script. This script, I mentioned about the temperatures and the mode, etc. This script is a very, very cool one. Actually, I'll probably get to that in a moment. Just to let you know that it subscribes to the messages and then controls my air conditioner. Let's just keep it at that at the moment. I've also got one that monitors the Peak Brothers weather station that I've got and uploads the information to the CWAP. Oh, so first part, monitors the weather station, puts it into the PubSub server. Second part, uploads to the APRS servers with the weather station data. One of the other cute things I can do with all this is there's the interface to my alarm system. And so I decided to run, it has a nice little LCD on it, and it's got 16 characters, and it can swap between 2 different lots of 16 characters. So what I decided to do was to extend the functionality and decided to work out that I could display information here. So what I've done is, and you can't see it right there, is display how much energy I've produced on my solar since the start of the day. Also, I've displayed the outside air temperature and the air conditioning control, the temperature set point. And so as I go out the front door, I can see how cold it is outside and how much energy I haven't generated on the solar system. All because it's a very, very simple system to add functionality. XMPP I won't bother about, Modbus Solar, blah blah. Okay, web interface. So I wrote myself a little web interface, works really well on the iPad and iPhone. I use this thing called iWebKit and the Twisted Python infrastructure. Twisted is the name of this library, network library for Python, and it's slightly twisted, but once you get your head around it, it's slightly less twisted. It works really well, and basically what this allows me to do is I've got HVAC programs, which are basically automated programs that are based on certain conditions. Lounge room lights, weather, solar, alarm, energy, what lights are on, bedrooms, night light circuits. So what I can do there is monitor and control the home. This is just an interface to PubSub Server, so I can do anything through it. Such as weather monitoring. Up here it tells me temperature 10 degrees, at 85% humidity, no wind, barometric pressure 1014.2 hectopascals, and temperature inside my garage is 16.68 degrees. So it's a fairly simple way of actually producing a very nice interface. Home energy monitoring. At the moment I'm using 41 watts for lights, and I'm not using any hot or cold water. That tells me how much power and what my average power consumption has been for the last minute, hour and day, and also how much water I've used in the last minute, hour and day. And it tells me that I've used 10 litres of hot water and 80 litres of cold water in the last day, which gives you an idea of how little water people can use if you only have 5-minute showers.
So sorry, so the power reading, so what's that coming off? What sensor?
That one is actually just computed from the light switches.
From the lights, yeah.
I think, remind me afterwards, I think I've got the photo, I think I've included information here on my other scheme for monitoring power. If not, ask me about it.
Well, that's an app on your iPhone or iPad, isn't it?
No, it's a web page.
Oh, it's actually a web page, right, okay.
It
Just
uses
looks
this,
like an app, okay.
yeah, it's called iWebKit.
okay. Sorry, I didn't understand that.
Yeah, and it's actually just got all the style sheets to make it look like an app.
Yeah, otherwise you're going to jailbreak on your device.
Yeah.
Okay.
Yeah, but no, this is just a straight website, which makes it, you can extend it as much as you want, and it's really, really easy to create them.
Right, and that's just going to the server side of the PubSub.
Well, it's actually going to, I've written a little standard Apache thing,
Right.
and that connects to PubSub. So this is the energy monitoring, solar monitoring, the same sort of details. This is the cute one. I've broken down the house into like room, master bedroom with 3 different lights, bathroom with the different lights, hallway. And what I can do there is they've got on-off slider. So if I turn touch those lights go on and off.
See the toilet candles and
Well, in my toilet, I've got 2 light switches. One, I've got the lighter only, and the second one does light and fan. In the bathroom, I've got light and fan. I accept 2 heat lamps, 4 heat lamps. Plus, also in the bathroom though, because I cheated and used the 1mm wire, I technically can't use, in the middle of summer, the 1mm on the neutral is a bit small for the heat in the roof, so I'm not allowed, under the regulations, to use both heat lamps if the temperature in the roof is over 40 degrees. So, all 4 heat lamps, which is what, over a kilowatt. So, how many people use an IXL Tastic with 4 heat lamps in the middle of summer? But that's some software. Okay, remote control, and this is just for the bedroom. And so I've also created a special screen just for the master bedroom with the 2 downlights, toilet and bathroom. So I can just do as a very, very simple web page. So just control them. Okay. Actually, I might talk about the energy consumption here right now. Unfortunately, I don't think I've got the slide. What I did there, I worked out that the best way to monitor energy consumption was to do it from the fuse box. So from Alibaba, I bought some current transformers for all of $2 each, I think they were, and bought 8 of them. Current transformers just clamp onto outside of a piece of wire, and they monitor the current that comes out of them is equivalent to the current going through them. So it might be 1 amp. If it detects 1 amp, it will push an output of 1 milliamp. The important thing is never to run the current transformer unloaded, because they're like putting a backwards transformer, and you can kill yourself on high voltage. So what I did with that was I had these 8 current transformers in the switchboard. So then I did some really, really dodgy circuitry. I then built a half-wave rectifier for each of these signals with some capacitors to drain to create a very, very, very nasty AC current signal to DC voltage signal converter. It's not particularly linear, but it does actually work. And so what I've then had was 8 different voltage signals coming out. And so with the signal, with the same signal devices that monitor the light switches, they had one which had 8 analog inputs on it. So I fed that into that. So every 5 seconds or so, I monitor the current consumption on all the circuits in my home, and so I can correlate that as well. It's got an error of 10 to 20%, but it gives you a rough figure for the energy consumption. I now know of the better way to do it, but it involves a chip that's fairly well unobtainable unless you like quad flat pack designs. There's a very, very nice chip that I found with dual core for like $8 or something that will do all the computations and tell you absolutely everything you need to know, including power factor, current, power quality, voltages, you name it. Very, very nice chipset. Okay, HVAC, heating, ventilation, air conditioning. My air conditioner. I used to have a open fire in my place, which we'll talk about in a moment, but it was useless. And so got a split system air conditioner. Notice that there is a, well actually no, there's not, is there? There's no computer interface to those things. They're a real pain. There's not even a control panel. Some air conditioning units have this thing called a 4/5 wire ANSI interface, which actually is 4 or 5, I think it's 4 relay outputs to allow you to control almost any HVAC device. Well, actually that used to be how things were done. Nowadays things generally are done with infrared. So I've got this air conditioning unit here, and I need to be able to control it. So how do you control it? Well, the first thing I did was I bought a spare remote control for my air conditioner, and I hacked it. I grabbed the buttons, the up and down buttons, and connected a relay to the up button and a relay to the down button, and connected that up to the lighting system. But the problem was that whenever I wanted to change the temperature, whenever I restart the software, it had to recalibrate, which meant pressing the down button about 16 times, just so that you could know what the temperature was, and then pushing the temperature back up to what you wanted. And I didn't think that was particularly the best idea, considering that it also required you to, it also beeped every time you press the button. So that was a bit of a disaster. Then I came up with a better solution, a toy solution. A USB infrared toy, actually, from dangerousprototypes.org. Well, actually from Seed Studio. And this is a device that sells for around $20, including postage from China. Has an infrared has an infrared receiver, has an infrared transmitter, has a PIC microprocessor, a USB, plus a TTL level serial port on it. for $20 built. And it has a serial command line interface. So what I did was wrote a tiny bit of software for this thing to connect to the PubSub server, reverse engineered the protocols used by my air conditioner, of which there are about, I think, 258 different IR codes, and worked out how to send them here. Once again, the LED is sent over Cat5 cable to the patch panel. And the emitter is at the top of the stairs, and it's in a standard wall plate with a little hole. It's hard to see here, but there's a little LED there, and you really don't notice it, as it just works. Web control here, on-off slider, set pull down for temperature, fan speed and mode, heat, cool, dehumidifier. Or you can go into these selected programs. Winter out for the day, adaptive, or not home. The adaptive one's interesting. Let's say it's winter time. Well, it's not quite winter time yet, but it's coming. And let's say that it's 15 degrees outside. If it's 15 degrees, you might cope with it being 23 degrees. But if it's 10 degrees outside, you'll think that it's warm at 20 degrees inside. People adapt based on outside temperature, and the colder it is outside, the colder you can cope with it being inside, and you won't notice. And each degree of change there will actually save you a huge amount of money in your air conditioning bill. So that's why the adaptive is there. Back-end software, I think I've already talked about that. Vacuum. One of the other things I wanted to do was, my vacuum cleaner was about to die. And so I thought, what's my options here? I can buy a Dyson. They're about, what, $1,000, aren't they? Or I can do something decent. And what I was finding was that I was using a rechargeable vacuum fairly often, and not wanting to get out my large vacuum cleaner. So I thought, what can I do here? And then I visited a friend's. Basically, it wasn't too hard. For those who have never seen it, it ended up costing about $1,000, the same as a Dyson. And it's just plastic tube. Just like installing plastic pipe in your home. I've got another slide in a moment. And the way that it works is, inside here there are two little metal contacts. The hose itself has got a little ring around it, so when you put it in, it creates a short, which turns the vacuum cleaner on. And so what I did, I got upstairs I had two inlets, one near the bedrooms, one near the kitchen. Downstairs I put one in the rumpus room, one in the garage, which is fantastic. Great to vacuum the garage. And another one out in the carport, so I can actually clean my car. Here's you can see that I got a bit messy with the blue stuff, but it's better to have too much than not enough. And the little trick just is to make sure, and this is looking from, that's at the top. The main thing when installing the ducted vacuum is to make sure that, if possible, you have stuff fall down, not up, and have it going so that any stuff comes this way and there, so you can just see this join goes that way as well. It's actually not too hard. I needed to, in the my rumpus room, I wanted to have the inlet in my rumpus room, so what I did, that was the only room I had a major problem, so I took out the wall, a thin bit of the wall in the games room in my garage, installed it, and then re-gyprocked. For those who have never learned how to gyprock, it's a great time to try to learn. And this is an idea of the vacuum cleaner. You don't need a heap of filter with it because basically you push all the air out to the outside and you don't need to worry about the filtering. Okay, fireplace upgrade. Now what's he doing with a fireplace with this house? Can anyone see any problems with this photo?
TV probably doesn't like a fire, aren't it?
Well, yeah, that's sort of the problem, isn't it? Well, this is actually the end result, not the start.
Oh, the plasma gets into your HF radio, so it's useless.
HF, that's 144 meg, isn't it? High frequency.
That's where the real radio happens.
Worked all bands starts at 144 megs and goes up to 800 terahertz. Anyway, yeah, my home is a 1970s home, and what I've got is a brown feature wall.
Brown everything, in fact.
No.
It's green bar.
No, it's not that bad. Basically, the room's fairly large. It's around 6.5 metres by 4.5 metres for a lounge room. Plus, there's the dining room off to the side, so it's a reasonably large room for modern standards. And the fireplace was used once. The fireplace doesn't work. The chimney doesn't work. So the best chimney was actually the lounge room. So the air conditioner works far better. And the room was set up so that on the long wall was where the TV was, or long wall was where a standard TV was, not plasma, and it did not work at all. So what I decided to do was change things around a bit. So I mounted the plasma TV on the fireplace. And of course, how do you then hide the cables? You jackhammer straight through the brick wall, don't you? Into the chimney. And run all the cables through the chimney. By the way, I'm now onto my third Bunnings rotary hammer drill / jackhammer. If you notice, I've got a nice scar up here. That's from the butt of a rotary hammer drill that got stuck when I was drilling into a wall. That was 8 external stitches and 3 internal stitches. Yeah, I love my rotary hammer drill. I'm not quite to the stage of Badal Garby, who then gets his vacuum cleaner out whenever he's digging holes in his backyard, and uses his vacuum cleaner to remove the dirt from the holes, but I'm close. So here is what all the equipment looks like in the fireplace, which wasn't all that appealing, I don't think. So, I've spoken earlier about how I've actually built a plane. Well, I didn't stop at building a plane, or what's the other way of putting it? You should use rivets everywhere, I think. Not only should you use rivets to build a plane, you should use rivets to build a home. So, I got some AutoCAD out, and got this bit of aluminium cut using a laser cut, and then put it together using aircraft grade rivets and an aircraft grade aluminium squeezer, and all the parts that you needed you'd use to build an aircraft. So then what I did, I put it on some sliders. You might notice the sliders just here, but can anyone notice something else here? Right at the bottom. It's a screen. So I've got the huge plasma at the top, but I've also got a screen. A fake fireplace! Which we'll see in a moment. Yeah. But so behind the curtain, I needed to, being on the second story, I had to get the jackhammer out once more and jackhammer through the floor of the fireplace. And you can see the 4 lots of coax. Here's the banana plugs for the surround sound for the room, and there's 6 Cat5 here. You can never have enough Cat5, and I think I'm using about 4 of them at the moment, which means it's probably time to run a bit more Cat5. And on the other side of the fireplace there's the inlet for the power. And to give you an idea of what it looks like,
Working fireplace.
A working fireplace. And the trick here was, it's actually a dark piece of perspex, so that and everything behind it is dark. So when the screen is turned off, you can't see anything that looks like a fireplace. Turn it on, you see the fireplace. You pull it forward, and you can see all the equipment behind it. You can put DVD or Blu-ray discs in. There's a remote control extender, so everything works like normal. And no one can touch no little fingers or any can get into parts either.
Darryl,
Yes?
when your media server PC catches fire, how are you going to be able to tell?
It's an Apple. It's
We'll
perfect.
vent it to the lamp room. So you'll know.
The smoke detector's hooked up as well, you know.
But no,
You send an email, you're on fire.
yeah. Yeah, the media server's an Apple TV, so it never gets upset. It never breaks down. Okay, downlights. Downlights are a pet hate. Basically, a normal halogen downlight is something like 35 to 50 watts each. In a lot of modern houses, the kitchen may have 8 or 10 of the darn things, which means you've got a load there up to 500 watts. If they are on 24 hours a day, which they won't be, but if they were, that would be $1,000 a year, divided by 3 for 8 hours a day, and that's what, $350 a year from downlights, just for a kitchen. What a waste. So, there are better solutions. LED lights are expensive, but what I found was that my local lighting shop had compact fluorescent, standard screw-in compact fluorescent downlights for $12 each, with a warm globe. They ran on 240 volts. Sure, they weren't dimmable, but who cares? And they just worked. You connected them up, and they worked really well. And they had that nice warm colouring if you wanted that. And so what I did with my lounge room was right around the edge. I've now installed 12 of the darn things, and have a relay on each so I can control how much light. And the two closest to the TV, I've splurged. I've put 5 watt downlights in them. So if I have both of those running, that's 10 watts. It's nothing. If I turn all the downlights on in my lounge room, it's 185 watts. So that's a heap cheaper. They don't last quite as long as some other lights, but they're cheap to run, and they turn on instantly. So it's something to check. And to give you an idea of what they look like these days, that's the standard light, and that's with the downlights in the bedroom. So that gives you an idea of the sort of effect that you can create with very, very cheap downlights. Like $12 each, you can't lose. Even if you have to replace the globe every year.
What electronics do you have behind the picture frame there?
I didn't set that up either. Technically, it's not those picture frames, and but no, these one of the things that I was having problems with was I've got a heap of stuff that I want to electronics that I want to display, and some of it's actually quite valuable. I've got a 16 kilobyte memory card at home. 16 kilobyte, you think, why would that be valuable? Well, it's actually 4 different cards, PCBs, this size, core memory, and originally sold for more than a new car. It actually came out of Manly-Warringah or Vales Point Power Station mainframe, and was a 16 kilobyte core memory board. Core memory, for those who are too young, which is most of you I see, is every single bit is actually a donut, ferrite donut. For 1 bit, 1 donut, on a grid this size. So 16,000 times 8, whatever the math is on that. That's how many of these little donuts there were. with 3 wires going through each of them. And so they're actually a very valuable collector's item. I also had some other pieces of equipment. So what I did was went to my local frame company and down in Ingleburn and got some of them mounted. So this is a generation 1, 2 and 3 iPod. And they're behind glass, you can't touch them. What I first did, of course, was to remove the NiCad batteries and threw them away. This is actually a taper TNC1, based on 6809 from memory. And it costs about 50 to 60 bucks to get these mounted. So here's one of the, that's 1/3 of the core memory board. Unfortunately, I didn't put the cores there. That's from a Westinghouse W2500 mainframe. So it has a great, if you do printed circuit board work and want to show or have old pieces of equipment, it's a great way to actually turn them into something arty and make them actually look nice.
We've got a coffee table.
What was that?
We've got a coffee table.
Yeah, well these don't generate, don't collect dust.
Oh, we put glass on top.
Oh, okay.
Arcade machine,
Oh, good. Yeah. So, interesting discoveries. Finally. I found some very, very interesting discoveries when I was doing the rewiring. That is one of them that was in a junction box.
It's pretty typical.
Unfortunately, that wasn't the worst. And what even more unfortunate is that one of the worst still exists in the home. I counted 7 different cables going into one light fitting. I still don't know how they fitted all the cables in, but the problem was that I couldn't replace the light fitting because it was above the stairwell, so it's still there. However, it now only has one wire going in, and all the others go into a junction box with nothing coming out. So it's a lot safer. But that was probably the safest of the interesting discoveries. So, one of the other ones was on the 1970s home. Remember those lights where you had this bit of metal fitting up the top with a cord coming down and then another light hung down? So, let's have a think. How would you mount one, or how would you wire one of those up? Well, with one of them, they decided that they didn't have enough screw connectors, so they twisted the switched active together and taped it. No screw connector. However, that's the competent one. I think that was the competent electrician. Then they got the incompetent electrician. So with the incompetent one, they decide to do that to the earth. However, not to be outdone, they then had the unswitched active to do something with. And they didn't think that it was quite right to leave the unswitched active just taped, obviously. So connected it to the chassis of the light fitting. The unswitched active, the bit metal up the top, unswitched active.
Well, that could be by accident.
I discovered it when I was rewiring the place. As I said, I'm not an electrician. Thankfully.
You leave that for your insulation in.
Yes. Well, actually, I wasn't eligible for the insulation because I already had insulation. So when I installed the insulation in my roof, I didn't do what most people did, which was rip out all the existing insulation, then put all in new stuff. What I did was I realised that I already had R2 or R2.2 insulation. So instead of throwing all that out, I got 2 or 3, all the insulation I already had, I made it 2 or 3 layers thick, and then put new insulation in everywhere else, which meant I recycled the existing insulation and got the entire roof insulated. The other little trick, by the way, with roof insulation is that you can now, for about $35, get a little draft stopper for exhaust fans. They open automatically from the air pressure, and they stop hot air rising through the exhaust fan. You can buy them at Bunnings or electrical wholesalers. Well recommended. And so the question from the start. So why do my lights come on at 3 a.m. or alternatively, why did my light stop working within half an hour of my 40th birthday party where I invited all my friends over? Well, the first one was, or the problem with the birthday party one, well, that was a software bug, and I changed from an ASCII protocol to Modbus, thinking that Modbus would be more reliable, and then finding out that the Modbus library was a bit buggy, and so was the hardware. So, make sure if you're inviting people off to show a home automation system off, make sure you have the software running for several weeks before you invite people over. As for the second one, or the other one, why did my lights come on? Well, I outsourced the programming for this. I figured that someone else was paying me some money to do this work. If I paid someone else to do them, if I was getting paid $1,000 a week, if I could pay someone else $50 a week to do the work, I could spend the week off and earning $950, which I thought was a fantastic idea. So, I outsourced it to a guy in Turkey, which of course has different day times. And then started wiring, gave him access to the scripts through a VPN connection and access to the hardware, and then started wiring up without actually telling him. And so the light in my stairwell then got connected to the hardware. So he started testing the script at 3 a.m. and it woke me up. And so I went down, reset the hardware, went back, tried to get back to sleep. The light came on again. Thought, stuff this, turned the circuit breaker off, went back to bed. And then worked out the next morning that, yep, he had been working and testing his code.
At least you know he did something.
Yeah, exactly. And he did a very good job. Turkish programmers, fantastic. Indians, not so good. Questions?
Okay, first question. Why did you go for the relay bank as opposed to distributed control?
Cost. Because the reason I didn't go for distributed control like C-Bus or something was that I wanted to be able to monitor everything, and also the cost of C-Bus was going to be a lot more expensive. It turned out to be about, each light turned out to be about $10 to $12, whereas C-Bus was going to cost around $50 per light or something. So it was a huge price difference.
Even wiring it back to your relay board?
Yeah, even wiring it back. So I think with the wires it came to about $15 per light. And then C-Bus would have required a lot more wiring as well. So I did the cost-benefit analysis, and some of them were going up to as much as $200 per light switch for a lighting control, which did not meet the cost-benefit analysis, which meant that basically for $5,000 I was able to control the house rather than the 25 or 30 for other systems. Yep.
What became of X10 technology?
X10 still exists, but it's all over power line, therefore it's susceptible to interference. It's sort of going into home plug and a few other technologies. Zigbee is sort of the heir apparent, but hasn't really caught on, except that that's slowly becoming more popular. By the way, Zigbee is the ideal solution for home control. It's a mesh system, protocol stacks. But if you check with Alibaba, the most popular Zigbee appliance, by the way, anyone might have a guess what the most popular Zigbee device you can buy is for home, which is a home automation type thing. No? No?
Toilet flusher.
No? No? It is alignment tools for your wheels of your car. Why that would be the most popular Zigbee device, I have no idea, but that's like when they do a wheel alignment of your car with the lasers and everything, that's the most popular Zigbee appliance you can get. Alright, any other questions? Alright, well thank you very much for having me, and I hope to be back at some stage and I'll tell you all about building planes.
Well done, Darryl. Would you like a drink?
Yes, please.
What would you like?
Diet Coke.
Yeah.